This video will be an introduction to radian measure. We'll start out with a circle. You'll notice that the center is marked here and a radius is drawn. Now I've cut a piece of string that measures approximately the same length as the radius. And what I'm going to do is mark this length around the circle. So we'll start here at the 0. And we'll mark off one string length is approximately here. Now this measure is 1 radius, and the angle that's formed that subtends that arc is 1 radian. And a radian is abbreviated RAD. So 1 radian angle measure subtends an arc that's equal to the length of the radius of the circle. Now let's continue marking off our radius. So this arc measure is, the length of it is 1 radius, but the angular measure is 1 radian. So this is 1 radian, and this would be 2 radians. Here we have 3 radians. Four radians is down here. Five radians. And then is about 6 radians. Now we'll notice that we have a little bit left, and this is actually all the way around is 6.28 approximately radians, and you'll recognize this number as 2 pi. So we know that all the way around the circle is about 6.28 radians, or 2 pi radians. Now if I go ahead and show the diameter of the circle, you can see that all the way across here is pi radians. So it would make sense that 3 radians would be a little bit less than 3.1415 radians, which is a semicircle. So let's practice this a little bit. Here we have our circle divided into 4 equal parts. Now remember that you need to look at just the semicircle. So just this is pi radians. So if we were to label our angle measures in radians, then this is 0, and over directly across from 0 would be pi radians. Now because we have pi radians divided into 2 equal parts, then this measure up here is pi over 2 radians. Pi over 2. So to get our measurement here, we can count off. This is 1 pi over 2, 2 pi over 2. This is going to be 3 pi over 2. Now we can assume if there is no angle measure on our angles that it's in radians. So if you want to do degrees, you have to show your degree symbol from now on. If there's no notation of what type of angle this is, then this is in radians. So when we have our semicircle divided into 2 equal parts, this mark at 90 degrees is going to be pi over 2 radians. And then a full semicircle is pi radians, and then 3/4 of the circle is 3 pi over 2, and then this one would be 2 pi also, 0 or 2 pi. All right, now let's look at this one. We have our semicircle divided into 4 equal parts. Again, we start at 0 on this side, and this one is pi. So that means, since it's divided into 4 equal parts, that each part is 1/4 of a pi. So this is 1 pi over 4. This is 2 pi over 4, which we know reduces to pi over 2. We already said that this vertical line is pi over 2. And then, so 1 over 4, 2 pi over 4. This one will be 3 pi over 4. This is 4 pi over 4. And let's continue around. This one will be 5 pi over 4. And then this one is 6 pi over 4, which reduces to 3 pi over 2. And we already saw 3 pi over 2 over here. So let's continue. Let's see, 6 pi over 4, and this will be 7 pi over 4. And this will be 8 pi over 4, which we know is 2 pi. So until you get used to your radians around the circle, it's helpful to just count those off. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. And make sure you reduce the ones that can be reduced. Let's look at this. We can see this time that our semicircle is divided into 6 equal parts. And again, 0 is over here, and this is pi. So each part is going to be 1/6. So this will be pi over 6. This will be, so 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and 12 pi over 6. Now reducing these, this one won't reduce. This is the same as pi over 3. This is pi over 2. This one's 2 pi over 3. This one won't reduce. And this is 6 pi over 6. 7 pi over 6 won't reduce. This one's 4 pi over 3. And this one reduces to 3 pi over 2, which we saw on all these other ones. This one is 5 pi over 3. And then 11 pi over 6 won't reduce. And then 12 pi over 6 is the same as 2 pi. Now let me also point out that one semicircle, if we're going to compare this to degrees, one semicircle, let's start up here. We said that this was 90 degrees. So we can say then that pi over 2 is the same as 90 degrees. Now it's helpful if you can think just in radians, but let me go ahead and put these equivalences. This is 90 degrees. This is 180 degrees. This is 270 degrees. Now if we take our 90 degree angle and divide it into 2 equal parts, each of these are 45 degrees. So this is pi over 4 is the same as 45 degrees. And this is our 90. And then this one is 135 degrees. And here's 180 degrees. And then adding 45 to this one would give us 225 degrees. And this was 270 degrees. And this one is 315 degrees. And then 360. And kind of looks like Christmas. And then up here, when we have 180 degrees divided into 6 equal parts, each of these will be 30. So this is 30 degrees and 60 degrees. So pi over 3 is 60 degrees. 90 here, 120, 150, and then 180. Adding 30 here is 210, and then 240, and this one's 270, and then 300, and 330, and 360.